the summary, basically verbatim what's up here. Basically what we're looking at is where are the places that robots as we conceive of them today don't fit a need that industry has. That might be in automotive or aerospace or agriculture. Lots of different industries could use some kind of physical automation, but because of the weight or the expense or other shortcomings of our conventional robotics, they don't fit that need. At the same time, these are industries that are also in the process of making autonomous systems. So we think of cars and aircraft today, and the autonomous versions of those things in the future. For example, autonomous vehicles or aerial drones, even satellites. Autonomy is coming to a lot of the things that they make as well. So the goal of this panel and this discussion is to basically talk about what are some of the unmet needs in those industries and what are some of the goals of those industries. So if you're making a device, a product, a material that might be able to help solve one of those things or might be able to become part of a future product, that will start to make those connections and make that understanding. So this is really sort of pre-networking, getting everybody geared up for the reception and things like that are coming. And one of the key areas where we see this innovation happening is in material science. So a lot of times when we think of robotics, we think of electromechanical systems. In fact, I would say that's the default, is we think of something that looks kind of like a metal human, C-3PO being maybe the most representative of the genre. But anybody in this industry knows that that's not the case at all. Robotics can be anything from a single arm to an automated way of, again, delivering packages or all kinds of things like that. Again, that's the setup, the point of this panel. And I'm going to start out leading out with just a little bit of an introduction to soft robotics and a way that we've started looking at soft robotics as a potential area for innovation. So you did hear panel introductions. I do, however, have one correction. Bob, if you're here, I haven't seen you. We were very fortunate to have Peter Marcotilio from SRI step in at the very last moment. You've probably seen SRI in the Expo booth, and you'll see in just a second why Peter, I think, will be a good substitute for our otherwise missing panelists. If Bob comes up, we'll get him a chair. All right, so as I said, I'm going to set up the panel with a little bit of an intro to soft robotics, and then I'd like each of you to talk a little bit about, again, some of the things I said. What are you doing right now in robotics? Where do you see some unmet needs in your industry and some potential things? And how could you basically connect with some of the people that are here in the audience? Really briefly about Lux Research. So we're a research company that does research about research. In other words, we're looking at these roughly 20 different areas over here on the side where universities, startups, other innovators are coming up with new technologies. We're looking at things like patents, we're looking at venture investment, and we're basically seeing where are these research areas going and how are they turning into commercial products. So that's the end of the advertisement. This is a specific area that we cover, robotics, within our Autonomous Systems 2.0 practice. And I saw my colleague Mariana, who presented earlier today about logistics and transportation. This is her core area of expertise. So soft robotics. I assume everybody here has at least heard of the concept of soft robotics. If you have, please raise your hand. Okay, so a few people that haven't. So what are soft robotics? Well, soft robotics really simply is just using soft materials to make robots. So things like polymers, textiles, things that, again, are not the metal and plastic that we tend to think of as robotic materials, but they might be, new kind of nylon. It might be literally a textile or plastic, things like that. And there are some adjacent areas that this touches onto. So things like computing composites, those are smart dust in coatings or structural materials. Chemical computing, people are looking at using chemistry as a way to actually calculate and solve problems and the changes, chemical changes, turning that into information. Tangible interfaces is a big area in UI design, user interface design. A good example of a simple tangible interface is your keyboard, but a better example, I think, is actually a robot. A robot is a way that we interact with machines and machines interact with the world, so input and output there. There's some other types of things you can see here with, you've probably seen some of these squishy robots that can crawl across the surface, or origami robots that can fold themselves up. So conceptually, that's what we're looking at. And earlier this year, back in June, we basically pulled together a workshop where we brought together the different disciplines that are, again, just starting to touch, that are bringing together the soft robotics community. So one, obviously, is robotics experts. You can't make soft robots without robotics experts. So we had a number of people from Silicon Valley Robotics, for example, some of the robotics developers who are represented here, come together with advanced materials developers. So these are companies that make, think of Dow, DuPont, Evonik, BASF, these companies that are making tons and tons of materials, and they're always looking for the next new big application of the fancy new thing they provide in their lab. And then finally, the applications and users, as I think we all know and hope to see even more of. There are a lot of industries where robotics could apply, but penetration outside of, say, manufacturing in very closed, structured environments has been pretty low. So there's Bob, actually, right there. So Bob, we got started without you. We have an adjunct. So we now have a baker's dozen on our panel. And so Bob, I'm just setting everything up, and then we're going to talk about applications, and I'm sure you're going to do awesome because you're good at winging it. So these communities all know each other really well, but they don't, within those communities, but they have, for the most part, never talked. Soft robotics requires material science as well as robotics, but most robotics people don't know much about material science, and vice versa. So what we did is created a workshop that SRI, Peter's organization, was very, very helpful in hosting. So SRI, Stanford's Foresight and Innovation faculty, a company called the Innovation Leadership Board, and Lux brought together about 30 or 35 people from those different disciplines for an all-day workshop at SRI. And we actually turned this into a LinkedIn group, so if you want to look at soft robotics development, apps, and investment, you can join our group. And we did things like this. There was, first, just people talking with one another, standard lecture, presentation type of things, so that we could all get on the same page and understand each other's disciplines. We then went into some facilitated problem solving, so looking at prioritizing needs and looking at opportunities, again, with these cross-disciplinary groups, and even doing things, this is a lot of fun, I have to say, making prototypes. So you can see, I don't know how well you can see from, this is kind of low and dark, but this is a table full of paper prototypes made of things like, plastic bottles and tape and markers and things like that. So that people that, had never met each other by, the end of the day were putting together ideas for new methods of locomotion using, for example, melting and solidifying wax so that these soft legs can move over a surface. You see somebody's got kind of a soft prosthetic on their knee right there. So it was a really, really interesting opportunity for people not just to, think about the future and look at a bunch of bar charts and stuff like that, but actually have a hands-on interaction with materials and with each other and with these ideas and put them into practice. So I mentioned SRI. They were the host, and some of their researchers were really core to making this work. They've been in robotics for 50 years, back when robotics were obviously even earlier stage than they are today, and have a lot of experience in a lot of the component systems in soft robotics, as well as robotics generally. We also had Rita Sunspiral, who's a researcher at NASA Ames, working on a really, really interesting new concept in robotics called tensegrity robots. And the best way I think to explain this is if you know these toys that kids have that are kind of sticks held together by rubber bands. So he's taking that idea and applying it to robots that might run around on Mars, for example. So a typical rover today that hits the ground like that rover is pretty much done for. And what he's looking at instead is you take a ball like that and you kind of let it hit the ground, it squishes and it then fixes itself and rights itself. And by adjusting the tension and the length of those different cables that are holding those bars together, it can actually make it tumble across very rough surfaces or fall down hills gracefully and get up and keep doing their job. So really, really different approach to robotics. And one of the things that you can actually do, actually building on the open source software presentation we just saw, is you can go to his toolkit that he's made available on GitHub, and you can do modeling and simulation of very, very biomimetic, like this sort of caterpillar-like structure that you see at the bottom. Really, really complex robotic systems that deviate quite a long way from the traditional way we think about robots. One of the other companies there was Other Lab, specifically their robotics group. So this, I think you can kind of see from here what's going on. You've got something that looks like a standard, robotic arm with joints and movement and a gripper at the end. But this is all made of basically nylon tubes. So if you think of like those, those kind of floppy robot guys that stand up at car dealerships sometimes, imagine that, but sealed up and with very, very precise motor control. So they can pick and place boxes and do all kinds of things. But if this robot comes along and whacks you in the head, your head will not fly across the room. It's just, you can see it's actually hitting with a hammer and then it goes back to its job. So, one of the things about soft robotics is not just the safety component, but it obviously these weigh a lot less than a conventional robot. The cost and time to deploy and modify and upgrade them would also be a lot less. So this is potentially a real game changer in how we think about them. There's a company actually called Soft Robotics. That's their name, and that's what they do. So they make grippers. In this case, you can kind of see they're gripping fruit. And one of the things that's really interesting about them is how they use machine vision to essentially do that, do the positioning and the gripping. So not just using sensors in the actual polymer itself, but actually looking at what they're doing and using that as a way to precisely control what they're doing and where. Another company, actually an SRI spin-out, is called Grabbit. I saw Charlie mention, the CEO is Charlie here right now. So somewhere here, Grabbit is somewhere at the conference, Grabbit is walking around. So Grabbit uses electroadhesion. You can kind of see from these fingers that look a little bit like old 35mm film. They can grab onto various objects and then using basically electrostatic adhesion, pick them up, move them around, and you don't have to sort of plan in advance exactly how big and where this object is going to be so you don't crush it. It's a very soft, pliable way to pick things up and go. As I said, we're rethinking, I should say, a lot of the basic ideas about robotics. And once I heard a Marine robotics developer saying there will never be an autonomous Marine. There isn't an autonomous Marine today. Every Marine is part of a team. They all work with other humans to get their job done. And any robotic Marine will do the same thing. And one of the things that they're looking at in the military is another type of an adjunct to human strengths, and that's exoskeletons. So again, SRI has an exoskeleton project. You can actually see it over in the exhibit hall. And then another Other Lab company called Other Lab Robotics is also working on these. Basically, Iron Man suits, except they're soft. They're lightweight. They can augment your strength, but it's a little bit more like wearing a suit of clothing than like climbing into some big metal contraption like Sigourney Weaver did in the Aliens movies. So a lot of things are going on. Like I said, a lot of new ideas, and there's still a lot of science. So even if you go back to the lab and look at what's going on the material level, you see a lot of new and interesting approaches to making the substance actually that the robots are made of, so that those things can then become have embedded sensors or embedded actuation. So the material itself will be part of what we today think of robotic functions. So hopefully that's a good just intro to the breadth and depth of the things that are going on in the soft robotic space. I hope that's been really interesting. I'm going to go to our panel, and the four questions, the four takeaways that every presentation at this conference has are basically what we're going to try and address. I don't think this will take us the full, I believe we have roughly about 30 minutes left at this point, and we're going to try and get out on time. So we won't take the entire time. I'd like you to start now and start to get some of the types of questions you'd like to ask our panelists. So, as I said, to start out, the first thing we'd like to know, what are some unmet needs? Where do you guys see in your industries something that, hey, if we had some way to automate this human task or some way to do this with more precision, that would be great, but there's no solution out there right now. And I'd like, if you could, you could also just say a little bit about yourself more than just your name and your title, maybe just a couple words so we also know something about you. And Bob, you want to start out?
Sure, hi.
Punishment for being late.
Thank you. Bob Christopher, I direct innovation at Panasonic, a small company out of Japan. My background is robotics. I built a couple robot companies in the past, and I spent a lot of time thinking about a lot of the challenges these companies are now, that Mark is recently showing, how they actually develop products. One of the challenges that I see for robotics is new materials for sensors. So how do you embed sensors into structure in robotics that has tactile, haptic feedback, that knows the pressure of something, that knows the strength it needs, I mentioned motor strength it needs to navigate and to control itself. So I'm really interested in really the embedded sensor space and the new materials to support that. I understand Park, SRI, and Orange Labs are all working on different various technologies to support that. So I'd love to learn more about that space. That's my question.
Hi, I'm John Sundy, head of Heavy Ventures, which is the company's corporate venturing arm. We invest in lighting technologies, which are mostly for automotive applications, sometimes manufacturing, and sometimes in the car space. A little bit back about me. I actually got in my early career, did some work with MEMS actuators using polymer materials to make essentially robotic arrays that could either be used for manipulation or for locomotion. And then I went to work for Xerox PARC and some work in modular robotics with the idea of having robots that be built with specific components, more of a Lego block type of style where you can have the same component, put them together in different ways to make different shapes and so on. I want to maybe paint how in automotive, at least, the use of soft robotics has been in there, but maybe hidden in plain sight, if you will. So if you bought a car anytime after, say, maybe 1990 or so, you actually have a car with a soft robot. We call them airbags, actually, right? And we don't think of them as robots because they're not manipulating anything, they're not doing any locomotion, but it's a device or a system that is used to hail you in case of a crash, right? So it's like a Big Hero 6 in that movie, but it's like stuffed in your car, right? And if you see a modern day car advertisement, and you look at all the airbags deployed, it looks like you're inside of a marshmallow, right? It's like all puffy and white. And so in automotive, we actually use a lot of what we might think of not as soft robotics, but actually is deployed in these cars, and it's used again to create a view of your passenger in the case of that. And nowadays, there's a lot of sensors in there, not just for crash detection, but for passenger number, location, seat position, height, weight, that sort of thing, more and more. So these airbag systems are becoming more and more intelligent. So we don't think of them as robotics, but I think in a lot of ways they are. But having said that, I think there's a lot more to be done. There are talks of using airbags outside of the car, not so much for pedestrian safety, but for additional crash protection. And I would also say that some of the soft robotics that have been on the screen here are looking at how different types of manipulator designs can be made in a more lightweight version for a new type of car suspension or a different type of wheel chassis design as such. We can talk about that a lot later, but that's just sort of some more far-off concepts that are possible. Thank you.
Mathieu Robin, I'm with the Airbus Group. I belong to corporate strategy. I'm with them since 2 years, and I'm focusing mainly on, let's say, long-term trends, new technologies, and the impact they can have on the overall aerospace industry. I would say lots of our products are already robots. If you think about a plane or satellites, a satellite is supposed to remain autonomous for something like 15 years. Planes, I would say the less human intervention, the better. Still, it's good to know that there's a pilot in there. As a passenger, I prefer to know that someone shares the risk. For us, I think on the product side, the technologies are there. It's more a question of regulation and certification. These are the main challenges. Regarding new materials and things like that, I think for us, where there's an interest is really in manufacturing. There's a big difference between aerospace and, for example, automotive. Automotive, I don't know how many cars are produced per day, but I would say, well, thousands is possible.
Yeah,
No, but I mean, one big factory, maybe 300,000. Fine. So we do base case 1.5 airplane per day. So it's a completely different way to look at automation. You have movie lines with the car, which is moving inside, let's say, along with the robots that are somehow fixed. For us, it's the other way. The robots are moving around the airplanes or around the helicopters. And so for us, it's really a completely different challenge. We're coming to robotics a bit later than automotive, and with different challenges. And for us, I think soft robots, for example, are very interesting because one of the constraints is really that we have humans everywhere in the final assembly line, which is not the case for automotive. And so anything that is soft and that will not hurt humans, the worker, is really something key. So cobots, for example, would be things that we are looking at. Also looking at exoskeletons that somehow are controlled by a human, and so it's the kind of things we're looking at.
Great. So Peter, you have a little bit of a different angle on this, but maybe you can see some of the companies you work with, or some of the other things that you guys are looking at addressing with soft robots.
Sure. So first of all, I'm Bob. And thanks for having me on the panel. My background is in helping move technologies from the lab into the marketplace. So been doing that for a few years at SRI. Several of the companies that you mentioned, like Rabbit, I helped spin out and create into a venture. We have been working on sort of soft robotics and alternative materials for a long time. As a matter of fact, one of the first companies I spun out of the Institute was something called Artificial Muscle, which was an early company looking at electroactive polymers to change the design space for robotics. It didn't quite achieve its mission, but it is still being used in automation. It was eventually acquired by a company called Parker Hannifin, and it's being used for things like pumps and valves in medical devices and in factories. From my perspective, the topic here about advanced materials and robotics is similar to the original artificial muscle story, which is changing the design space that you have for what you can consider a robot. So the more options you have in terms of materials that have different functions, maybe multiple functions. As you saw in other labs, you've got a structure, you've got a material that provides both structure as well as potentially functional interaction. You can think about embedding sensing into something like that. So you're now changing the design space of what you can achieve with a robot. The kinds of things we'd like to see are, I think, things that have been mentioned here. Robots that can, just like sort of humans and animals and other biological systems, robots that can interact in a different way with the real world. Right now, most of our robots are behind cages in factories, and as we move sort of outside the cage and into interactive, collaborative robots, cobots, you need to start looking at the different design tools that you have in order to achieve something that's safe and functional and useful and long-lasting. So I think that's where the advanced materials are, changes your design space so you can achieve something. Yeah, go ahead.
If I just add on to Peter, nice to know you, by the way. This is my first time meeting two of you. Nice to see you. I've helped launch a couple of companies in the last 10 years. One is a company called Jibo, which is a robot for the home. Cindy Brazil, the MIT Media Lab professor, is quite well known for Kismet and Waldo. She really developed the social robot industry. And if you follow Jibo, they've done quite well since they launched. It's JIBO. But I bring it up because my understanding for where I think social robots can go And that is really creating a relationship between people and machines. Whether it be in a factory automation environment where robots understand we're next to them and then want to knock our head off, like you're saying, or they ask us how we are, how they can help us, for example. But also more in the context of business environments, that, at work, you can imagine a robot delivering your printed document, or doing something for your work, or doing something, of course, at your house or in your home. So I think there's a lot that can be done there. Now, speaking of cars, my personal belief, this is not, by the way, it's not Panasonic, this is not personally, is that I think cars will actually begin to have more of a personality, and they'll interact with you as a friend. And at some point, we'll have a relationship with our cars and machines that we can't imagine today, but they'll know us and they'll interact with us and have empathy and understanding. And I think that's an exciting future. It probably does involve new materials and new actuators and sensors, but it also involves a new level of AI that's going to have empathy and social context built into it, where we will have a relationship with machines that is social, and we won't have to think about it in that way. It will be natural to us. So I built a robot called Clio. It's a robot dinosaur, just to be able to look it up. My co-founder is Caleb Chung, who built the Furby, and it was really a social experiment about how do you create a relationship between people and machines. And I think we got it right. It was actually quite a long journey to get there. Foxconn became a partner of ours who helped produce the product. But we sold a lot of Clios, and it was a good learning experience. So I kind of have a flavored opinion of robots based on that, but I see a lot of potential, and I think that's also going to push the boundaries in materials, because it'll become more, as we expect robots to be more like us or interact with us, the materials that we build robots with will also be advancing as well.
You had a soft skin.
Oh yeah.
We had a soft skin, right?
So that was fun. Yeah. So Clio had a soft skin, so that allowed it to be much more interactive than a hard plastic or something.
Right. That gave Foxconn headaches.
Yeah. Well.
Well, so that's actually a good segue into the next thing you're saying. So AI and soft materials. What are some of the things you think are ready, or like if Chibo's kind of one of the leading social robots today? Where do you see things that are ready for the market, and where are things that are missing? You don't see a solution, or the solutions are kind of too half-baked at this point.
Well, I'll speak briefly, but I think these people have more to say than I do. I think Rick Kurzweil is going to be speaking about the future of AI tomorrow morning. I think there's a much more simplified, actionable AI that we can do today that's more social. I think it's a social AI that has empathy, understanding, will be more useful to us, at least for the next, foreseeable future. An AI that has actual sentient self-awareness is, that's where I think people want to push it. But I don't think we have to get there to actually have an AI that gives us value. But that means various things. So that's my reaction to that.
Thinking about soft robots as manipulators in either manufacturing or maybe some locomotion application. What I'm not seeing yet so far is the controllability of that pneumatic soft robotic system compared to its mechanical counterpart. And in manufacturing, the need for precision is paramount. And so I think in the factory floor, though it would be great to have these robots which are lighter and inherently safer, I just haven't, maybe I just haven't seen it yet, but I think that would be one area of the controllability of these pneumatic soft robots would be, I think, a great area of need. And as that progresses, and I think it will, I think then we'll see them more in the factory floor, other locomotion applications.
Yeah, on most side, I think one of the characteristics we have is that the robot will be working inside our products, for example. So contrary to your activity where the robot is really on a concrete floor, all robots will actually evolve inside the airplane, and that there's a load constant. So if soft robotics, for example, can help building robots that are maybe lighter, that would be something really interesting for us.
Yeah, and to John's point, there's no way that these soft robots in the next few years are going to have that kind of precision. On the other hand, they are going to have a level of capability that allows them to go into other spaces where you may not necessarily need that precision, like a home or a retail space or inside an automobile. I really like the idea of inside the automobile, because the automobile is going to change. Our interaction with the car today is through hard touch points, right? And as they become more and more autonomous, our interaction is going to be much more of a sort of a multimodal living environment where you may not actually touch anything in order to control that car. And so that whole interface is going to change, potentially change dramatically. In addition to all the AI and all the intelligence, all the other things like that.
Yeah, so in the interest of time, we have about 7 or 8 minutes left according to the schedule, and I'm certainly happy to stay around, but I don't want anybody to feel like they've missed anything if they haven't or can't. If you would start thinking of your questions, I'm going to combine our last 2, and we have AV team, how do we do mics with people in the audience? Should they just stand up and ask your question, or do we have a mic we can pass around? We're like the least favorite team for the AV. We're like, they see us now. The panel, too many people on the panel. We talked a little bit about how you guys do, what's sometimes called open innovation. How do you engage with universities, with startups, with outside companies, maybe even with each other? Can you talk a little bit about your company strategy and your particular role in that? How do people engage with you?
Just really quick, as a corporate venture capital operation for County Motors, that's how we see that we are there to make investments in those startups with interesting technologies that are strategically important. So in that act, we then create hopefully a very good start to a meaningful business relationship and partnership. And we, from that act investment, we do a lot of work to either do product co-development or technology transferring activities, tech demos, pretty broad range of different things.
By the way, and neglected to say, they're all based here in the Bay Area, so walk on over and have coffee. Either of you guys.
Yeah, we're all based here, but for some of us, it's maybe a bit more research.
Yes.
So we announced in March, I think, or April maybe, that we're setting up an innovation center here, and also setting up a corporate venture capital arm. For the moment, the plan is really to run local projects. So we're currently recruiting team and setting up some local projects. Most of them not announced yet, but we're building infrastructure. So we're coming to the valley. I would say that's new for us. If you were talking about open innovation and interaction with startups, I think that's something we were already doing in Europe. We have well networked there. It's going to be new for us doing it here.
Oh, sure. So I guess a good example is the slide you had up there on the exosuit.
Mm-hmm.
It had MIT. It had I don't remember who the other groups were on that slide. So everything we do has some sort of collaborator. DARPA was self-funded. Because the technology is moving too quickly, there's too many opportunities. You want to focus on the things you do well and find the best possible partners on the things that you need help with. So there's always, we're always reaching out to the best in the world in terms of who to collaborate with, both in terms of our partners, clients, collaborators, etc.
I echo those comments and that strategy. That's what we do as well. I think we're all trying to find ways to find innovators to solve problems for us. And one of the things we did at Panasonic recently is open up all of our licenses for the public. So we have an open license strategy, which is now really a completely open API to our portfolio of technology to encourage third-party companies and developers to develop and take our technology and embrace it and go forward. So that's really a kind of industry breaking news for us. At a more local level, we're in Cupertino, it's like we're all local here, but we have partnerships with Stanford's accelerator called StartX, and we work with Plug and Play and other groups, and we look for innovation in those areas. Depends on our group. We're a very big company. We sell technology into automotive. We sell technology into the airplane industry, mostly in-flight entertainment systems of Panasonic, for example. Your rear view backup cameras in your car, mostly Panasonic. So lots of tech across the industry you just don't know as ours. But we're expanding, and we're looking for new areas to grow, of course. And I just, as a side note, I was participating in the PCH Hardware Hackathon this weekend and TechCrunch. And quite interesting. Ford was there, so was IBM and a number of other companies, to embrace innovators and look for ways to collaborate with new ideas. And very encouraging to see 1,000+ people hack together an idea overnight. And so, but I think those are the kind of activities that will bring new opportunities for companies like ours and our groups to find innovation and really inspiration from different people. So we're looking for that at Panasonic.
Okay, great. So I saw a few hands kind of going like this. I'm going to start right here.
Yeah, my name is Roy Sherrill. I'm from thenewsbubble.com. One of the areas that I think that robotics is going to be emerging in is telerobotics for virtual reality, virtual presence, telepresence, all this kind of stuff. Here I've got a 360 spherical video camera that I'm using for recording interviews and events and stuff. And the idea is to create a virtual environment so that the person who's watching the video feels like they're actually at the event. But I'm taking up a big part of the picture, and this is recording, it's full spherical video. So I'm building I've got a prototype that I'm working on that's a robotic rover to carry the camera around so that they can, record video that other people will do for either telepresence or virtual presence. So that, the viewer is controlling, either the rover or watching the rover without someone in the picture holding the camera.
Mm-hmm.
And I'm thinking that, a lot of that kind of stuff is going to be very important for emerging, robotics, and also, haptic control in a relation with that.
Sure. So that type of interface, do you have a question for one of the people on the panel about how that would work with their
have you guys,
or?
worked at all with this kind of technology, or?
Actually, I would say maybe it's slightly different, but in the aerospace industry, maybe in automotive, I don't know. We use already augmented reality, virtual reality, to, for example, explore a technical design. We immerse people into the CAD model of the whole airplane, for example. We also use augmented reality to perform some kind of inspection tasks. So you will just, for example, we have an iPad-based application. You put the iPad in front of you, it will recognize the environment and say, okay, you need to check this bracket, and this bracket, and will inform you about, for example, the doors you need to put on some of the screw or things like that. So I think these technologies, and especially also in automotive, for maintenance purpose, are technologies that have been looked at and that are used in some cases already.
Yeah. So I just had to note that the title of this slide is, exoskeletons are kind of the augmented reality of robotics. I think this cobots blends really well with that. There's a question in the back, I think.
Hello, my name is Mark Ting. I have actually two questions. So relating to manufacturing and soft robotics, I kind of imagine that the regulations for dealing with like a hard robot will be very different from the future with soft robots. Do you know if there's been any development in regulations on how humans can interact with these soft robots in terms of safety-wise? And if not, when do you foresee that these regulations will slowly come about? And my second question is, what kind of applications where we integrate hard robotics and soft robotics together do you know of that you see that there's most potential? That's my question.
So there's definitely work on the regulatory side in terms, there's already specs that robots have to follow in factories, which results in the cages, right? And hard stops and those kinds of things. As you started getting the collaborative robots, there are specs around the kinds of speeds and forces, the kinetic energy that the robot can sort of apply to a human, but you know, they're still being investigated as these new technologies hit the market. So there's a number of groups, mostly led in Europe, looking at different specifications of robots in the factory. And then the second question was?
So actually, I think
combinations of certainly some of the exosuit things where you've got hard actuators linked to soft parts of the body and interface. Those are obvious ones. But haptics was another one to your point.
Yeah.
That's an area.
So, sorry, I have to see we're going to get our heads cut off by not a robot, but by one of our hosts if we don't get out on stage. So I apologize we had to cut it so short so abruptly and didn't get to a lot of the other questions. But I believe, well, we have all day tomorrow and we have some time right now, so we'll exit the stage. Thank you all very much for your attention, and thank you. Please help me thank our panelists for and we'll see you around in the next day or so. Thank you.
Thank you. Okay, next is Pitch Fire, which is happening right now. So you want to attend Pitch Fire is in the Executive Ballroom 210A. So that's happening now. I'm trying to get everybody over there. Attending.
I need someone to unhook my extension cord.
Thank you very much. Thanks for your help.